Here we have a problem on integration, that is we have to evaluate this indefinite integral, and also we have to round our answer to 3 decimal places. Okay, now let me start working on this. Okay, initially I'm going to evaluate this one as indefinite integral, that is without the limits of 1 and 6. I'm going to find the result of the indefinite integral. So once I get the result of the indefinite integral, I will apply the limits, the lower limit 1 and upper limit 6. Okay, now let me start with an indefinite integral, that is 1 over x times square root of. Okay, my first step, what I'm going to do is I'm going to factor the coefficient of x square, that is 16, from the expression we have inside the square root. When I factor 16 out, then I'm getting x square negative 7 over 16 inside the square root times dx. Then integral 1 over x times. Here, square root of 16 is just 4. Actually, 16 and this one are multiplied. Since the square root of 16 is 4, we can move this 16 out of the square root as just 4. Then 4 times square root of x square negative. And now I'm going to write this 7 as a square. Actually, 7 is not a perfect square. In that case, what should I do? So it's very simple. I have to take a square root and then it has to be squared. And then 16 can be written as square because 16 is a perfect square. So it can be written as a 4 square times dx. Okay, now let me continue over here. Integral. Okay, so here this 4 is a constant. Since a constant is multiplied by the stuff which contains a variable, what we can do is we can move this constant 4 out of the integral. Since the constant 4 is in denominator, when it comes out of the integral, it will become 1 over 4. Then I'm getting 1 over x times square root of x square negative. Here we have square for both numerator and denominator of this fraction. Whenever we have the same exponent for both numerator and denominator of a fraction, we can take the exponent in common. Then we get square root of 7. Let me write it over here. Square root of 7 over 4 the whole square times dx. Okay, whenever an integration contains a part in the form square root of x square negative a square, what we can do is we can continue the integration process with the substitution of x equals to a times secant theta. Okay, now let me consider this particular part of our integration. It's exactly in this form, square root of x square negative a square. At the place of x over here, in our problem also we have x. At the place of the constant a over here, we have the constant square root of 7 over 4. So now what we can do is we can do the substitution in our integration. Okay, but the only change what we have to do is instead of a, we have to use square root of 7 over 4. Okay, now let me continue the process over here. That is let x equals to square root of 7 over 4 times secant theta. Okay, now I have defined x as a function of the variable theta. Since I have defined x as a function of the variable theta, I have to get this complete integration in terms of the new variable theta. When I get the complete integration in terms of the new variable theta, I must be getting d theta at the place of dx. For that, what I have to do is I have to find derivative on both sides of this equation with respect to theta, because x is a function of theta. Okay, now let me find derivative on both sides of this equation with respect to theta. When I find derivative of this x with respect to theta, I'm getting dx over d theta. So here it's a constant multiplied by the variable part. When I find derivative, if there is a constant multiplied by the variable, I have to keep the constant as it is. Now I have to get the derivative of this variable part secant theta. When I find derivative of this secant theta, I am getting secant theta times tangent theta. Okay, now to solve for dx in this equation, I have to get rid of the d theta in denominator. So for that, I multiply both sides by d theta. Let me do it. So when I do so, this d theta will cancel. I'm getting dx equals to square root of 7 over 4 times secant theta times tangent theta times d theta. Okay, now I got the stuff that is equal to dx, that's over here. Now we have to go to the integration over here. In this integration for this x, we have to plug in this square root of 7 over 4 times secant theta, and also for this x. Okay, now let me continue on the next page. Okay, let's continue over here. Okay, so on the previous page in this integral, I just plugged in this value for x over here, and for this dx, I just plugged in this stuff, and I got this is a step. So after substituting the required values, okay, now what we can do is we can cancel this square root of 7 over 4 here, square root of 7 over 4 here, and also we can cancel this secant theta and secant theta. Then I'm getting 1/4 integral 1 over square root of okay here. So the square root of 7 over 4 and secant theta, both of them are multiplied, and we have the common exponent. Whenever two quantities are multiplied and we have the common exponent, what we can do is we can distribute the exponent to each quantity and multiply the results. In that case, I'm getting square root of 7 over 4 the whole square times secant square theta, negative square root of 7 over 4 the whole square times tangent theta times d theta. Okay, let me continue here. 1/4 integral 1 over 4 square root of. Now, when I look at the stuff over here inside the square root, both the terms contain square root of 7 over 4 the whole square. So we can factor 7 square root of 7 over 4 the whole square. If this one is factored out, then we have just secant square theta left in the first term, and we'll have negative 1 in the second term. Because it's, this is completely factored out, we just have to assume there is 1 multiplied over here. When it is factored, we have 1 over here. So it's negative 1 times tangent theta times d theta. Okay, let me continue over here. Okay, so 1/4 integral. Okay, here two quantities are multiplied inside the square root, and for this one we have square. Since it's a perfect square, it will come out of the square root as just square root of 7 over 4. And inside the square root, we'll have secant square theta negative 1 times tangent theta d theta over here. Okay, now let me consider the Pythagorean identity, that is secant square theta negative tangent square theta, that is always equal to 1. Okay, in this one, I'm going to solve for secant square theta negative 1, because that's the stuff I have inside the square root over here. So if I solve for secant square theta negative 1 in this Pythagorean identity, I'm getting secant square theta negative 1 equals to tangent square theta. So now I can plug in this tangent square theta for this secant square theta negative 1. Okay, now let me continue with the integration. That is 1 over 4 integral, and also here the square root of 7 over 4 is in denominator. If I move this to numerator, then it will become its reciprocal. That is 4 over square root of 7 times 1 over square root of for this secant square theta negative 1, we can write tangent square theta times tangent theta d theta. Okay, so now next step what we can do is we can move this constant out of the integral, because it's multiplied by the stuff which contains a variable theta. So then we get 1 over 4 times 4 over square root of 7 integral 1 over, when I take square root for this tangent square theta, so it will be tangent theta times tangent theta d theta. Okay, here this 4 goes into 4 one time, so here 4 goes into 4 one times, and tangent theta will cancel it. We just have 1 times d theta over here. Okay, let's continue on the next page. We have 1 over square root of 7, because I just simplified the stuff we have over here in front of integration. That is 1 times 1 is 1, 1 times square root of 7 is just square root of 7 in denominator. And inside the integral, we have 1 times d theta. 1 times d theta is we get d theta, and we have 1 over square root of 7. When I integrate this d theta, I'm just getting theta. Okay, now I got the result of the indefinite integral, but I got the result in terms of the variable theta. Actually, theta is not the original variable. Theta is the variable taken by us. So the original variable is x, because we have done a substitution. That is, we have taken x as like a square root of 7 over 4 times secant theta. So now to get the result in terms of the original variable, what I have to do is I have to solve for theta in terms of x in this equation. For that, first we have to get of this fraction square root of 7 over 4, which is multiplied by secant theta. For that, we have to multiply both sides of the equation by the reciprocal of this fraction, that is 4 over square root of 7. Okay, let me do it. 4 over square root of 7 times x equals to 4 over square root of 7 times square root of 7 over 4 times secant theta. So here this 4 will cancel, square root of 7 will cancel. I'm getting, so we can write this 4x in numerator, that is 4x over square root of 7 equals to secant theta. Okay, now to solve for theta, I have to get rid of this secant. For that, I have to take arc secant on both sides. Let me do it. So arc secant of 4x over square root of 7 equals to arc secant of secant theta. Okay, so here we have arc secant of 4x over square root of 7 equals to, whenever we have arc secant of secant theta, that is equal to just theta, the stuff we have over here. So it is equal to theta. Now I have solved for theta in this equation in terms of x, that is arc secant of 4x over square root of 7. Now we can plug in this result for the theta over here. Then I'm getting 1 over square root of 7 times arc secant of 4x over square root of 7. Okay, so this is a result of the indefinite integral we started with. That is, indefinite integral is 1 over x times square root of 16x square. Then let me check it. Yeah, negative 7 times dx. Okay, now I got the result of the indefinite integral, but originally we have a definite integral. So with the lower limit 1 and upper limit 6. Okay, now let's continue with this step by taking the lower limit 1 and upper limit 6. Okay, now let me continue on the next page. Okay, let's continue. This is the result we got on the previous page. Okay, now to get the original integration, we have to take the limit for this integration. So that is a lower limit is 1 and the upper limit is 6. Okay, when I take the limits, actually these are the limits we have for x. When I take the limits for the integration on the left side, on the right side also for this result, I have to take the same limits of x. That is the lower limit 1 and upper limit 6. Okay, I am taking the limits of the lower limit 1 and upper limit 6 only for this particular part because this is just a constant. It does not contain the variable x. Okay, now what we have to do is we have to evaluate this one with the limits 1 and 6. Let me write the constant as it is. It is 1 over square root of 7. Okay, now what we have to do is we have to plug in this upper limit for x over here. Then I'm getting arc secant of 4 times 6 over square root of 7. Now in the same result, I have to plug in the lower limit 1 for x, but before that we have to take negative sign. Then arc secant 4 times 1 over square root of 7. Okay, let me continue here. 1 over square root of 7 times arc secant of 4 times 6 is 24 over square root of 7 negative arc secant of 4 times 1 is just 4 over square root of 7. According to the question, we have to get the result of this definite integral as a numerical value rounded to 3 decimal places. So we have to evaluate the value of this expression completely. If it is possible, we can use Texas Instrument and to get the value of this complete expression at one step. So I'm not going to use a Texas Instrument. I'm just going to use the regular calculator. So I have to evaluate each part separately and then simplify. Let me do it. 1 over square root of 7 times arc secant. First, let me evaluate this 24 over square root of 7. So when I do evaluation of this one, I am getting 9.0711 negative arc secant of, when I evaluate this 4 over square root of 7, I am getting 1.5119. Okay, now 1 over square root of 7. Now we have to evaluate the arc secant of this value 9.0711. Okay, before we proceed with this step, please make sure that your calculator is in radians mode, because in default usually the regular calculator will be in degree mode. So in that case you will be getting an answer as degrees. Actually degree is the unit of an angle measure. So if I want to get a numerical value as a result of an integration, so we have to keep our calculator in radians mode so that the result of this one will be a regular numerical value in decimal. Okay, so once we get the calculator in radians mode, now we can evaluate the value of this one, that is arc secant of this value. When I take arc secant of this value 9.0711 in radians mode, I am getting a long decimal, but I round it to 4 decimal places, then I am getting 1.4603. Even when I evaluate this one, I got a long decimal, but I rounded it to 4 decimal places over here and here as well. Okay, now let's evaluate this one, arc secant of 1.5119. So when I do so, again I'm getting a very long decimal value, but I round it to 4 decimal places and I'm getting 0.8481. Okay, now we have to simplify this one. That is, we have to subtract this value from this one. So when I do so, let me continue over here. I am getting 1 over square root of 7. So when I simplify this stuff over here, I am getting 0.6122. Okay, so here 1 times 0.6122 is 0.6122 divided by square root of 7. When I divide this value 0.6122 by square root of 7, again I'm getting a very long decimal value, but according to the instruction we have in the question, we have to round it to 3 decimal places. When I round that value to 3 decimal places, I am getting 0.231. So the evaluation of the given definite integral is 0.231.